Okay, perfect. So welcome to this second session about surge arresters from Tridelta Meidensha, and a special focus on the monitoring, the smartCOUNT device, new generation of monitoring to assess the condition of surge arresters. So we had our first session yesterday. I think it was quite successful. I hope this will be the same today. It's let's say the first of its kind that Tridelta Meidensha is doing this kind of online webinar. As you know, it was difficult for us, for the high voltage industry, but let's say for many companies to to see each other and to meet at the conference, exhibition, and business trip. So we are trying to reconnect through this let's say modern way. It's going to be difficult for me to cover all topics, and as I said, this is the first of its kind, and we would like to get let's say some feedback from your side. For example, yesterday there was somebody show interest about arrestor selection and configuration. I cannot go into the details today. I will just have an overview. And if you are specifically interested in topics, let us know, because we will continue this kind of session, online session with Zoom. So yeah, please feel free. You can actually ask questions. There is a Q&A module where you can ask questions. We will try to answer at the end of the presentation. We have 20 minutes. Here's the agenda. So I'm gonna introduce, let's say, my duty is to introduce the, let's say, the company a little bit, the portfolio, and talk about some technical features and overview of arrestor selection configuration. Then my colleague Philippe Raschke will take over and will give you some exciting information about the smartCOUNT. And we have like this 20 minutes for question and answers. So feel free to ask also those questions during the presentation. And we have Yuri, our moderator, who is checking everything. And if we cannot answer today, we will do it per email afterwards. So for a few people, Tridelta is not a well-known company. Just a brief introduction about the history. So actually, the factory in Helmsdorf, Germany, has let's say a long history. They started production of porcelain insulators in the 19th century, and since the 60s, they are, let's say, an established company for surge arresters, or say protective devices. We are also proud to share this common history with Meidensha Corporation in Japan, which is the mother company. In the 70s, they are, let's say, they claim the invention of the metal oxide technology, and also the first application in mid 70s. About Helmsdorf, Germany, the first metal oxide surge arrestor started in 89, and the first silicone housing product in 97. So as you know, the company Tridelta, so until 2015, we were Tridelta Überspannungsableiter. That means high voltage surge arresters. And since 2015, there was the acquisition from the Japanese group Meiden. So we also, for us, it's a interesting cooperation, because, as you know, Meiden is producing metal oxide varistors. Here you can see the global presence. You can see our mother company in Tokyo, Japan. Our factory is located in Helmsdorf, Germany. All our product are manufactured in our in-house. We have, let's say, a global footprint with surge arresters in operation in more than 120 countries. and let's say an efficient sales organization with more than 50 exclusive agents and sales representatives across the globe. I'm going to talk about high voltage surge arresters today. We don't really have the time frame to go into the details, and I don't want to describe the portfolio. I think it's not very exciting. We have for the high voltage, we have a complete portfolio, which is, let's say, quite typical for such arrestor application: porcelain housing and silicone housing. For the silicone housing, there are like 3 different design, which is the cage design and the hollow core design. I'm going to show some details afterwards. So let's say that we can cover almost all requirements with this portfolio up to 800 kV. Also important to have a look at the surge arrestor development over the last 30 years. There was some significant improvement, especially on the design itself, when the polymer technology, or let's say polymer material, was introduced into the high voltage industry. We have now the possibility to manufacture, let's say, very light polymer surge arresters, especially with a cage design. But also there was significant improvement in the MOV manufacturing. So maybe I will mention few features afterwards when we go to condition assessment. Tridelta is, let's say, proud to claim a complete portfolio for porcelain design. I like to say it's a compact by design. To give, let's say, for me, the best way to explain is that 30 years ago, the way the high voltage engineers were designing products are different than today. Today, we are looking at the customer requirements and we try to optimize the design based on the, let's say, the main countries that are using specifically porcelain or silicone. So we can say that the porcelain portfolio today is completely optimized and compact to address all different requirements on the market, which is different than 30 years ago, where the engineers had the responsibility to design a product based on their experience and their, let's say, their feeling. And that's why you can see on the previous slide such a huge surge arresters for 500 kV application, and today we can decrease the weight and also, I would say, the manufacturing time. So in the polymer family, we have the cage design. This is probably I think many people are familiar with this design, first of all, because it's competitive. It's a cost-effective solution. It's light, and it also offers a lot of technical advantages, up to, let's say, up to 400 kV system. Depending on your mechanical requirements, it's possible to use the cage design. It offers, let's say, interesting mechanical strength for, let's say, the ratio between weight and mechanical strength is quite interesting. And of course, excellent pollution performance, which are coming from the properties of the silicone material. Then the second design in the polymer family is the hollow core, also called tube design. You're going to see this design very often for extra high voltage, for 500 kV or 800 kV application. Also when there are specific mechanical strength required, and let's say quite often for seismic application and support function. It's also possible to combine two functions, surge arrestor and post insulator, if let's say properly, let's say consider during the design stage of the substation. And Also outstanding capabilities for short circuit. I do have an example. If it works, I check. It should work. Okay, so I don't understand because it worked only on Zoom. I think there is some issue to start videos. So you won't see the explosion. I wanted to have some some fun a little bit. Basically, you can, with this holocore design, because of its let's say robustness, you can achieve very high short circuit capabilities, up to actually in that case 80 kA, because this is let's say a requirement for the German utilities and also in Canada. You can achieve let's say very high short circuit values without any let's say without significant damage on the housing. And of course, for the seismic application, let's say you can fulfill almost all requirements depending on the let's say the diameter and the size of the tube. We have to find a solution for those videos. Okay, now I come to the arrestor selection and configuration. This is, let's say, a topic that cannot be summarized and solved in few minutes. I'm just gonna give you some, let's say, some bullet points. And if you have more interest, please let us know, because I think end of September, we're gonna have another session specifically for this topic. So basically, when you configure a surge arrestor, you have to focus in, say, in two directions. One is the electrical configuration, and the other one is the mechanical configuration. You should start with the electrical part, but before, it also makes sense to understand the advantage of the different design. As I said, the cage design is a cost-effective solution. It also provides a better heat dissipation that has, let's say, some important features for the protection level. And also, if you have special, let's say, very extremely high short circuit capabilities or seismic requirements, you're going to look more on the tube design, for example. So let's say from that perspective, you have already selected the type of housing that you need. So now if we go to the electrical configuration, the idea is to find the right arrangement of MOV staking. So if you look at the camera, what we call the MOV, the metal oxide varistors, or those blocks, that looks pretty simple, I would say. I'm sure that most of you are familiar with that. And we are playing with those blocks to reach the electrical requirements. So basically, if we talk about the rated voltage or the continuous operating voltage, we are going to play with the number of blocks. So the first step is to look at the continuous operating voltage, which is UC, so a phase-to-ground voltage that the surge arrestor can continuously withstand over its service life. Therefore, you have, let's say, a very basic calculation considering the maximum phase-to-ground voltage plus, let's say, a safety margin to include some harmonics and to be, let's say, on the safe side. Then when you have, and of course, I'm not going to go into the details. Depending on your neutral point configuration, you might need higher temporary over voltage, TOV values, that can increase your continuous operating voltage. So then once you have defined UC, you can, let's say, easily calculate the rated voltage. Very often you will see a factor of 1.25 between the rated voltage, UR, and UC. This constant actually is inherent to the MOV design. It has to do with the metal oxide technology. It's the ratio between the continuous operating voltage that the MOV can withstand over 30 years, 50 years over the service life, with the capability to withstand a temporary overvoltage for 10 seconds with prior duty. I'm going to give some more details afterwards. But basically, the ratio is fixed. It has to do with the MOV technology. Then comes the protection level, which is also called residual voltage. So the lower is the value, the better the protection level. What is important, and this is actually the main task of the surge arrestor, is to minimize and control the stress. So you want always the residual voltage to be lower, the BIL of the system to be lower than the insulation level of your equipment in the substation or in the transmission line. Then comes the energy ratings. Very important topic, because you want to make sure that your MOV blocks or dimension to withstand the stress coming from lightning or coming from switching. And there are two important MOV energy rating, which is the WTH, the thermal energy, and the QRS charge transfer. I have two slides afterwards that will, let's say, show more details about these two ratings. And basically, if you look at my screen, you will see that these two blocks, they have two different diameter, and the diameter of the blocks have to do with the energy rating. So the larger the block, and let's say the higher is the energy rating. But the larger is the block, and the more difficult it is to manufacture a block. So here comes the challenge. Now comes the mechanical topic, and let's say the selection of the housing. One of the main, let's say, also the key feature is the pollution performance. It's, let's say, very common that when you have a high pollution, let's say it's a very heavy contamination, you are looking for silicone housing, silicone material, because of its hydrophobicity properties. Then we have to look at of course, the length of the housing to make sure that the MOV column that was defined from the electrical configuration will fit inside the housing. Then we have to look at the insulation level to compare the, let's say, the safety margin between the insulation level of the housing and the protection level of the active part. Then comes the creepage distance. In some countries like Oman or like Saudi Arabia or Egypt, there are very high creepage distance required. Therefore, it's going to make the arrestor much longer. So you have the same active part, but you're going to use, let's say, more housing or longer housings. Then comes the mechanical requirements. The IC for surge arrestors, the 699-4, defines two important ratings for mechanical strength, which is SSL. It means specified short-term load. It has to do with the dynamic force coming, for example, from seismic or short circuit. And then comes the SLL, which is a specified long-term load that has to do with a static load, mainly coming from the conductor weight. Then we have the short circuit capabilities and the seismic loads that have their, let's say, their importance for the housing selection. I'm gonna, let's say, accelerate a little bit to make sure I respect the time frame. A very important topic is the installation coordination for such arrestors. You're gonna tell me it's obvious. Yes, it's obvious, because this is, let's say, the main job of the arrestor. But there is still, I would say, a misunderstanding that we see from our perspective in few countries when we, let's say, for different projects, when we configure such arrestors, there is often the requirements to have the same BIL for the surge arrestor than the system. And this is a kind of misunderstanding, because the surge arrestors, they protect the equipment, but they also protect themselves. Therefore, for me, the definition, and there is a conventional definition for the installation coordination, but I would rather prefer the definition to say that when it comes to surge arresters, the proper definition for installation coordination should be minimize and control the stress to prevent breakdown voltage of the dielectrical strength. The surge arresters limit the overvoltage thanks to their protection level and divert energy to the ground. Just the diagram, I'm sure that you're familiar with this diagram. The curve in red represents the different stress that you can see on your system. The important stress or the lightning of a voltage that are very short duration and very high amplitude, and the switching of a voltage, which are in the range of milliseconds and a shorter amplitude than lightning. So those two, let's say, transient overvoltage are quite problematic for the system. As you can see, they can exceed the withstand voltage of the equipment. So you want to avoid that, especially if you have valuable equipment like power transformers. Therefore, by installing surge arresters, you have the possibility to decrease, let's say, to minimize and control the stress. So when you define withstand level requirements, you always need to consider the protection level of the arrestor. Otherwise, you will have a kind of oversized solution. So just a summary here. As I said, the arresters, they protect themselves. So it's the responsibility of the manufacturer to tell you what is the minimum insulation level for my arrestor housing. And basically, the utility should not worry about that as long as the protection level is properly dimensioned and that the, let's say, protective distance are respected. The best example I can give is actually that when we go to the test lab to do the insulation withstand level for according IEC 8.2, you never do the test with MOV inside. Otherwise, it will never flash over because MOV will protect the arrestor. And when it's also very important when it comes to altitude correction and also minimum clearances. You always have, let's say, shorter clearances with surge arresters. So you have the possibility to reduce the, let's say, the distance between two phases or also from phase to ground. So just to summarize, always refer to the residual voltage. On this diagram, I'm sure you're familiar with that. This is the non-linear characteristic of the MOV, of the zinc oxide technology. So the voltage current characteristics, so current on the x-axis and voltage on the y-axis. On the right side, you see it's important to split this diagram in two parts because on the right side you have, let's say, the transient overvoltages, or let's say switching and lightning, and on the left side you have the, let's say, operating area and temporary overvoltage, which is, let's say, two different behavior for the arrestor. And what is really important, let's say, when you manufacture MOV blocks, is the ratio between the residual voltage and the TOV capability. So the lower is the ratio, let's say, the better is the, let's say, the performance of the block. To summarize, yeah, some specialists will tell me, but we are not going to the details here in this presentation. Now, I have mentioned before the energy ratings, and so one important energy ratings is the thermal energy from the type test called operating duty. So utilities have to specify this, the classification, and mention what is the thermal energy required on the system. This has to do mainly from the switching surges, so basically from the breaker operation. And it's also interesting because in the IEEE standards in the US, the test now is fully harmonized. Since 2020, there is a complete harmonization between IEEE and IEC. And this test is called switching impulse energy rating test. So to make it simple, this test is done on an MOV section, so which means very often 2 MOVs plus the housing, and the housing is important for the thermal behavior because you want to, the idea is to pre-stress the block with some high current impulses and preheating at 60 degrees. And then you want to inject the required energy, WTH. And after injecting the energy, you have to apply the rated voltage, which is like a temporary of a voltage for 10 seconds. And then you apply the continuous operating voltage for 30 minutes. And you want to make sure that the temperature is decreasing and comes back to the, let's say, initial values. And then you have to perform some tests on the block to make sure that they have not lost their initial characteristic. Another important energy rating is the QRS test for the charge transfer, also now fully harmonized with IEEE. This has more to do with lighting. The concept of the test is a little bit different because it's more, you are more looking at the mechanical integrity of the block. You are doing a kind of statistic analysis because you're going to use many samples of block. And this test is only done on the block itself. You are not looking at the thermal behavior, let's say. And you are injecting a specific charge, and you want to make sure that this charge does not damage the block mechanically or physically. And you want to make sure that the electrical characteristic that was measured before are the same after the charge stress. Now comes an important topic regarding type test. You know, very often comes the question of type test report and where do we do the test, and is it accredited and independent test lab? And I would say that there is a main difference between Tridelta, Meidensha, which is, let's say, a smaller size company compared to some of our competitors like Siemens and ABB, who have their own test facility. And we have to go to those independent test lab like CHESI or EGU, FGH in Europe. These are, let's say, experienced test lab which are focusing on energy on surge arresters. And I want to say it's important because you might see some differences working with CHESI, for example, or doing your test in your own lab, even though it's independent and accredited. For example, if you look at Tridelta test report, you will see that the type of MOV which is used is clearly written on the report. Also, if you go to CHESI for short circuit test, and if you fail the test and you have to repeat it, you're going to see it in the report. Yeah, you're not going to see only the test that has been passed. So these things I think are important when it comes to independence of test lab. Of course, Tridelta has the possibility to make our own testing. We have our own laboratory near the few meters from the factory. We can do almost all kind of tests except the short circuit, and we use it often for development and special acceptance test. I'm speeding up a little bit because I'm late. I'm talking too much. Here you can see some reference. So of course, Tridelta is quite proud to claim this reference for extra high voltage, and actually in almost all countries, utilities worldwide up to 765 kV system. And now I'm going to make a transition to the monitoring, and then Philip Raschke will be happy to take over. I'd like to talk a little bit about the failure modes of surge arresters, because this is actually the main point. Yeah, if you want to let's say, ensure long-term stability and long life expectancy of your equipment, you have to analyze what are the typical failure modes of such a arrestor. So I would say that typical failures that have been experienced on site or moisturing grass, it's much more common than on the distribution class than on the high voltage. I know the reason, but this is not the place for this topic. And actually, the failure rate in general for high voltage surge arresters, if it's coming from, let's say, responsible manufacturers, the failure rate is quite low. Huh? This is actually a general consensus. But there are some, let's say, failures that can follow search duties as thermal runaway or MOV failures that has to do with these energy ratings I mentioned before. So we, as a responsible manufacturer, we know how to prevent those failures with the type test, with the, say, the quality control and the manufacturing process. We are also able to prevent failures due to temporary overvoltage with the proper selection of the rated voltage, and of course looking carefully at the test result, the type test result. But there are two types of failures which are pretty common and that can be, let's say, assessed by using monitoring solution. And this is exactly the reason why we developed this, let's say, state-of-the-art solution. And Philip will give you more details about MOV aging, how to assess MOV aging, and how to assess moisture ingress on the surge arresters, because even though you can prevent this, it's, let's say, a very common question when you have an old substation with surge arresters for more than 30 years. How can you have the confidence that those surge arresters are still in good condition and that they protect your equipment? I think that's the main question. And of course, you can use smartCOUNT on new equipment, but it's also, it becomes an attractive solution because it's cost effective and it's, let's say, accurate and reliable to also to be installed, to have a, say, an accurate assessment of the condition on the old, let's say, old equipment. So I'm gonna now hand over to Philip Raschke, which is he was the product developer for this application, and he's our specialist in R&D. So yeah, I'm actually very excited that we are talking about this because for me it's today it's let's say a very attractive solution on the market. Our competitors are going to phase out their monitoring solution, and some of like the ABB, for example, has released a new solution which is smartCOUNT 3, which is a different approach, a different philosophy of monitoring. And also when it comes to cost, it's also one of the main topic. Why would you buy a device which is more expensive than your surge arrestor? Doesn't make sense. You can just buy a spare in that case. So yeah, so I'm quite excited because this device is cost effective. It's also accurate, and it's not something that we develop in 1 year and that we are selling. It was a 5 years development, and Philip will give you all those details. So thank you for listening, and
Okay, Florent, thank you for this revealing presentation. Meanwhile, we had one question in the chat, and maybe you like to answer in between.
Sure.
And in the chat, it was asked why we use silicone housing surge arresters, even if the SSL value and the SLL value is lower than porcelain housed surge arresters.
I'm not sure to get the question exactly.
Can you open the chat?
my microphone. For silicon housing, the specific short-term load and specific long-term load is much lower than the porcelain. So why we recently using silicon housing for surge arresters? I can choose protection level. Okay, these are different questions. So I think the question is coming from a specific country, probably from a specific utility and application. So well, there are different ways to answer this question. Yeah. First of all, we have to look at the specification from the utility. Why would you offer? I would turn around the question. Why would you offer an oversized solution while you can use, let's say, more compact with different mechanical values? It has to do with the requirements. For example, if we look at the short term, which is the dynamic stress, this is let's say the main dimensioning factor is the short circuit forces. So let's say the forces that are generated from the short circuit current between two phases mainly, and this has to be calculated. It depends on the distance between the conductors. It depends if you have a conductor, if you have a bus bar. It depends on the sag of the conductor. It depends on the short circuit current. Also, it has to do with the wind loads. It has to do with the seismic application. And so, yeah, I think the question here is mainly between the cage design and the porcelain. So I would say it also depends on the countries. These days, we see a lot of utilities which are switching from porcelain to silicon, and it's just that with the, let's say, with the existing portfolio, you can easily fulfill requirements with a cage design up to 500 kV system voltage. So that's the answer. But then you will see in some, for example, in Germany, or I don't know, in Quebec or in France, you are not able to use those cage design because you have some specific mechanical requirements. So it's all about mechanical requirements. And also I have seen from the substation, it depends how you connect the arrestor. Very often you have, like, I don't know how you call it, like a drop connection to the arrestor. So very often you don't have any, say, static force because the conductor is coming from the top directly to the high voltage terminal of the arrestor. So it's really different. And in Germany, you have a bus bar often which is connected on the surge arrestor. So this is a completely different installation. So I would say I can answer more precisely. Maybe you can send us. I don't know from which country comes the question, but you can send us more details, and we will try to be more accurate in the answer.
So thanks again. For all other participants, please use our question and answer section on the low end of the screen. There's a symbol of speech bubbles, and you can put your questions inside. And at the end of the presentation, we will pick one by one and try to answer. And if it's a question which goes very deep and which is not answered in with some short sentences, I would ask you to give this question by mail or later after the presentation, so we can take our time to answer it properly. Okay.
Okay, so I hand over to Philip. Thanks a lot.
So welcome everyone to part 2 of our webinar. Thank you for the introduction, Florent. I will now talk half an hour about the new monitoring system of Tridelta Meidensha. And let's start with an overview. On the right corner, you see an image of the device installed on the surge arrestor and some specific parts and components belonging to the whole system. And if I would summarize what smartCOUNT is, I would say it is a new generation of monitoring systems for assessment of gapless zinc oxide surge arrestors. And of course, it has some features and benefits I have put on this first slides to get an overview and get an idea of what it is capable of. So one thing I want to point out at the very beginning of this presentation is that this device is suitable for any gapless zinc oxide surge arrestor. So it's not only for Tridelta products, it will retrofit, it will fit on any gapless surge arrestor brand. It's maintenance free for its lifetime because it has a self-sufficient power supply coming from the leakage current. It has done some really severe tests like IP67 and some tests for UV light, temperature, and weather influence. And here comes some technical features. NFC is a new technology which we are using to read out the data. And one important point is the resistive current calculation, which is not only state of the art. It's I would say it's the most modern way to calculate resistive current. I will tell you later, of course, according to the IEC standard. We have a very high resolution of down to 1 microamp, and also impulse counting and amplitude measurement is of course one important feature of the device. Then we have an online solution which we call smartCOUNT Cloud, and also an Excel solution for the data evaluation. And we give email alerts to show you if a surge arrestor is in bad condition. And last point, and also important, we will give you a free expert support channel. If you have questions, we will try to answer properly. When we talk about surge arrestor monitoring, normally 2 basic functions are required to make health assessment on a surge arrestor. At first, this is leakage current monitoring, and for the smartCOUNT, we speak precisely about an automatical leakage current data logging, which is important to receive something like a leakage current trend. And on the other hand, of course, impulse counting has been and is still used to do some health assessment on the surge arrestor. More or less, it's useful if you understand the behavior, maybe together with the leakage current, then this is an important point as well. For the leakage current data logging, we can log a full hour each day or each week, just like you prefer. This happens automatically and cyclically, so you don't have to care. The device does it by its own. And for the impulse current measuring, it happens, of course, also automatically when a discharge in the surge arrestor is taking place. And it will be recorded with the amplitude measurement, with the date and time, and in a range from 100 amps to 100 kiloamps, so very wide range of current measurement. The main components are the data logger. This is where the whole measurement takes place and where the data is stored before they are picked up. And we have the possibility to store 1,000 records for leakage current and 1,000 records for discharge current. And yesterday we had the question, what happens afterwards if the 1,000 records are full? Of course, we can go on measuring, but it will start rewriting the first, let's say, memory cells. This is what we call cyclic buffer. So you can come after 5 weeks, if you have measured once per hour, then those 1000 data cells are full with leakage current records, and you can pick up the data, or you come later if you have chosen an interval of once per day. Second component, the smartCOUNT transponder pad. It is the device which is responsible to download the data from the data logger. It's like an antenna, and it works with near-field communication. In short, it's NFC. And this data communication is provided by almost each up-to-date smartphone. And you can quickly download the data from the data logger within some seconds, depending on how much data is stored on the data logger, of course. And for this function to read out the data logger over the NFC interface, of course, you need some kind of transceiver. And in that case, we have decided to take just a common smartphone as a transceiver. Of course, the smartphone should be Android phone and provide an NFC antenna. That's important. And you need to install our Tridelta smartCOUNT app. The smartCOUNT app will cover all the features the smartCOUNT needs, like configuring, reading out data, or also manages your account data. Yeah, important. And we give it for free on the Google Play Store. Here you can see. The fourth important component of the smartCOUNT system is the smartCOUNT Cloud. smartCOUNT Cloud will later on collect all the data you have downloaded from your data logger. Of course, you need to upload this data to the cloud, and inside the cloud there will be the calculation of resistive currents based on the third harmonic currents measured by the data logger. And it will also provide you a very nice website where you can access all the search arresters you have configured and you have installed on your all the smartCOUNTs you have installed on the search arresters will appear there. And you will also see the related search arrestor data you have configured before. So which search arrestor is it, on which transformer is it located, in which substation is it located, just as you configured. And you will also see the related leakage current data to this search arrestor, and you will see the related discharge currents for the certain search arrestor. If you don't like the online solution, we also have like an offline solution where you can download all the raw data to Excel from your smartphone. Very easy. The basic data handling I will show you inside this animation here. We have on the right side the smartCOUNT data logger with the transponder pad mounted on SBKC search arrestor, and on the top of the screen you see the smartCOUNT cloud. And of course now we need to go there with the phone and tap it on the transponder pad. It depends on which phone you have. Sometimes it only needs 1 centimeter distance between the transponder pad, but some antennas are very strong and it works within 5-6 centimeters. And if you tap it there, the app will automatically download the data from the data logger to the smartphone. Then the raw data is stored in the smartphone. As I said, you could now download as Excel file, but what we really want to do is connect to the Wi-Fi or connect to mobile and upload this data on our smartCOUNT cloud, because then you are able to access all those data related to your search arresters, related to your user account from a smartphone, from a desktop PC, from a tablet, doesn't matter. So you can access the data from anywhere in the world where you have an internet connection. You just need to log into the smartCOUNT cloud with your user registration. And this is how it looks like if you open the related website. On the top, I have put the link smartcount.tridelta-meidensha.de. And here you will find an overlook about your registered search arresters in the smartCOUNT system, and some information about their location and their voltage and the product code and so on. And if the manufacturer is Tridelta or someone else, date of registration, and of course, if data is available. And now you might click on the first search arrestor, yes, data available, I want to see it. And then you see like an overview about leakage current measurements, which has been taken automatically or taken by hand. There are several ways. Here we see it's like a cyclical recorded leakage currents at 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock. So this is automatically generated leakage current measurements. Very low resistive current, of course. This is an example for a very special search arrestor configuration with low peak current and low resistive current. And on the low end of the screen, you see impulse current measurements. So it looks like 2 impulses have been recorded. One was 1 kiloamp and one is 10 kiloamp, and they have happened on the 6th of November in the year 2017 at 2 p.m. or 3 p.m. So this is the overview you will see. And of course, everyone likes diagrams and to overlook it optically. That's why we have included also a diagram on the very top of the site, where you will see the different leakage currents in a kind of trend, and you will see also those discharge currents. I will show you now which current is what and what does it mean. So you have the green line, which is called peak current. So that means the peak of the total leakage current. And we have the blue line, which is the resistive current, which has been calculated right from the third harmonic of the search arrestor leakage current. And of course, this resistive leakage current is always lower, much lower than the peak current itself, as long as the search arrestor is healthy. So this looks like a healthy search arrestor with very, very low resistive currents. Then we have this red line. This red line we give for Tridelta search arresters. We call it critical leakage current threshold. It is related to the resistive leakage current. So once your resistive leakage current would exceed this line, the smartCOUNT cloud will decide by its own and send you an email with an alert, and will tell you, okay, this search arrestor on position 1 or 2 has maybe a problem. Please check and decide by your own what to do. And last but not least, we have those black bars you can see. This is the discharge current. We have one discharge current here with 100 amps and one with 1000 amps. You can see on the right axis of the diagram the values of those black bars, and of course they are placed on the date, or maybe also on the date and time of the timeline of this diagram. So you see not only the amplitude, you not only see the search count, you also see the date and time when it occurred in this diagram. So this has been an overview about, let's say, the basic functions, and now I would like to go on and try to explain 2 very important questions. And those questions are asked over the whole world, and I hear it again and again, and now I try to explain why it is like it is. The very first important question: why should I monitor my search arresters? Like Florent said before, maybe the monitor is almost as expensive as the search arrestor. I could just get a replacement search arrestor in exchange in the moment the search arrestor is defective. Yes, so why should I monitor search arresters? One important question. And the second, if I monitor search arresters, what are the main reasons for a search arrestor failure, and how can I detect them? So I would like to put some light on those two questions. Let's begin with, why should I monitor surge arresters? The argumentation chain is very easy. So you have surge arresters in your grid, and they are protecting your primary equipment against damages due to overvoltages. If there is maybe 1 out of 1,000 or 1 out of 10,000 surge arresters, let's say a black sheep among all the surge arresters which are normally highly reliable, there might be one that is damaged, maybe because of some duty it was not designed for, maybe a high discharge current, maybe a mistake in the manufacturing. This might be a seldom case, and you will say, okay, it's such a seldom case, so doesn't matter. What should happen? If the surge arrestor is faulty and the MOV block, maybe 1 or 2 MOV blocks are defective or degraded or whatever, the surge arrestor maybe is not capable to protect your primary equipment in the next incident when a lightning strike hits the line, or we have switching over voltage on the line. So what could happen is that the insulation of the transformer is broken, and of course this is a very drastic picture, but this is something which could happen if the insulation is broken, and you don't want your transformer to break down or explode. Of course, this will lead to maintenance cost and also to blackout, and you want to prevent this. How can we prevent this? We need to install a surge arrestor monitor on our surge arrestor to find this one surge arrestor in the whole surge arrestor fleet which is or which becomes defective. So you can't say I have a replacement surge arrestor, because at the moment the surge arrestor breaks down, you are not there, or you don't get it. You will not receive any information about the health of the surge arrestor. The aim is to find surge arresters when they get bad and before they fail. And of course, a surge arrestor monitor costs, or let's say should cost, only hundreds of dollars, and the transformer is worth some millions. So you have to consider this. So now we decide to use a surge arrestor monitor, which is smart and which should be done to, let's say, confirm the steady health of a surge arrestor. Then we will ask the question, what are typical failure modes of the surge arrestor? And afterwards, how can we detect those failure modes? So at the left corner of the screen, I show a cut of a surge arrestor. This is the typical porcelain surge arrestor with a, or this is a tube design surge arrestor from Tridelta, as I see, with enclosed air volume. And of course, this surge arrestor has a sealing system if it is having an air volume. So it has to be sealed with some kind of gasket on the top and on the low end of the surge arrestor flanges. And in the right middle, you see those green elements, which is the MOV block column. First thing we always talk about and we always consider when it comes to surge arrestor monitoring is the degradation of the zinc oxide varistor, which has been the classical case for years. You have to pay attention that your MOV blocks keep their health, and if they don't, the zinc oxide current rises and you run the risk of a thermal runaway. You have to pay attention. This is one of the most discussed failure modes, even if it's not the most common failure mode anymore, because surge arresters and zinc oxide blocks have been becoming highly reliable in the last years. Second, and in my opinion, most common breakdown reason for breakdown of a surge arrestor is humidity ingress. So you might have a surge arrestor which is pretty old, and the sealing system is not as fresh anymore, and gaskets have been aging, or something went wrong during manufacturing, then you have the risk that air and humidity ingresses into the surge arrestor housing, and you will quickly have some humidity condensating on the inner surface of the porcelain housing or the fiberglass housing, or maybe also on the zinc oxide column. And if you have a humid layer inside, of course, you run the risk of an inner flashover, and you also get inner surface currents. Third reason for surge arrestor breakdown, and this is sometimes forgotten, but I will mention it here, is surface pollution. If you have surge arrestors in high pollution areas, you will most probably get a conductive layer on your surge arrestor housing, and then you get outer surface currents, and you run the risk of an outer flashover. So these three cases can appear, and we have three kind of currents. I have displayed here with the red, blue, and yellow arrow on this cut view of the surge arrestor. And in the next 3 slides, I will explain you how we are capable to measure those currents and how to distinguish between those 3 cases. At first, of course, zinc oxide degradation. This can easily be observed by a rising resistive current, and this is the only case where we have a continuous rising resistive current. This happens due to degradation of the MOV blocks, and this might be due to an overload of the MOV blocks or some mistakes during manufacturing, which shouldn't happen if you're a good manufacturer. And the result from this is an increase of the peak current, but a significant rise in the resistive current. And with the smartCOUNT device, we have the possibility to discover this, and I show you how. Those values have been taken with the smartCOUNT on a surge arrestor, which has been degraded step by step. And that's why we see here stage 1, 2, 3, 4. And we could say stage 1 is a healthy surge arrestor, normal condition, and stage 4 is a heavily degraded surge arrestor. And you see that the relative increase of the peak current is much lower than the relative increase of the resistive current. Resistive current between stage 1 and stage 4 degradation is rising for almost 900% of its initial value. So this is a very clear indication that the surge arrestor is slowly degrading. So with the resistive current, the power dissipation inside the surge arrestor is rising. Of course, it will get hot, and you will quickly run into a thermal runaway. And this has to be discovered before, of course. But we are capable to do that. Second failure mode, humidity ingress. Therefore, we need the peak current to indicate this, this failure mode. Humidity ingress is the most common reason for surge arrestor failures, because conductive layers can appear inside the surge arrestor, and they will create high peak currents, which are somehow fluctuating and not steady. And I will show you how we measure that with the smartCOUNT. This was a laboratory test with a special prepared surge arrestor with failing sealing system and with water ingress. And on the left side, you see this MOV block where a humid layer has been developing on the surface and across the whole MOV block section, MOV block column. And of course, this condensed water on this MOV block is like a conductive layer. And you will quickly see this conductive layer in the peak current, like we see in the diagram, right? If sunlight shines on the surge arrestor and the surge arrestor is heating up, the water vapors inside the surge arrestor and condensates, and quickly after some hours, you will see highly peaking, spiking peak currents, total currents in the diagram with the red curve. There we see 10 and more milliamps, 16 milliamps, and the value goes up, down, which can't be foreseen, which the value is in the next hour. So this is a very clear indication for humidity ingress inside the search arrestor. And the third case, surface pollution, it is somehow similar, but the difference is that the surface of the search arrestor, if it's polluted and wet, of course has something got to do with the weather and with the surrounding of the search arrestor, and there might be also the possibility that the surface dries off or cleans afterwards after rain. So you will see the weather influences now on this behavior. It's just the same like with humidity ingress. You have a conductive layer, you have high peak currents, and therefore we show how we measure it with the smartCOUNT. Again, we get the diagram, and you will see some kind of reoccurring, cyclically reoccurring spikes in the peak current, and maybe also they are rising successively, like you see in the diagram. This might have something to do with slowly increasing contamination of the surface of the insulator of the search arrestor, and like we see here on the right side, this has been a search arrestor which was heavily contaminated by salt, fog, and dirt and water, and also the the transponder pad of the search arrestor of the smartCOUNT looks the same. So this can be very easily detected and also distinguished because we have this connection to the weather conditions, maybe to morning hours condensating humidity on the surface, and on the noon daytimes we will have sunlight and the surface is drying off and the peak current is dropping back to its initial value again. Typical case for surface pollution. And to put everything in some picture which is easy to understand, I've made these pictograms for the surface pollution here. Normally arrestor is okay, you can clean it, and afterwards the peak current would return to its initial value, and you have this high spiking currents from the humidity ingress, which is failure mode that has to be paid attention directly. So where we would say, please replace immediately or call us and check with us. And we have the third case of the zinc oxide degradation, which is, let's say, a slow process where you have to look for the trend of the resistive current and maybe check more frequent and ask the manufacturer if it's maybe all right, or if there is something bad happening to the search arrestor, or simply replace the search arrestor preemptively. What I clearly want to point out, all those cases, all those failure modes are only detectable if you have a leakage current trend. If you don't have a leakage current trend, if you only have some single measurements of total current, or also some single measurements of total current and third harmonic current or resistive current, it will not give you the same information content like we get here from the smartCOUNT. So here, through search arrestor monitoring and search arrestor health assessment takes place. Summarizing, the smartCOUNT is capable to discover all the typical failure modes which can appear in the search arrestor. So now, after this theory, I want to show you some real-world and laboratory experiences. We've been installing the smartCOUNT in several countries within 3 years, carrying out intense field tests from all different conditions you might imagine, and from various applications of surge arresters. And today we have hundreds of devices in service, and we have learned very much within those 3 years, and we don't regret to take this time, this long time, to verify the quality and to optimize the quality of the device. So that was the very early beginning of the first devices which we have installed in a substation very close to our factory. Classical retrofit installation on existing surge arresters. Very easy, just to bend down the cable and install the smartCOUNT data logger, and then let's say carry down the cable from the transponder pad and install it on the bottom of the steel structure you see here. Took us 8 minutes for one set of smartCOUNTs. Very easy installation and very good results. We have 2 installations in Slovakia, Low Tatra, 123 kV, and here we have something got to do with rain, ice, and moisture with one of our customers and partners, which was a very good cooperation here. Found many things which we had to work on the device. We have an installation in Brazil, coastal and tropical climate, challenging for surge arresters and for the monitoring system as well. And here we have a very interesting installation in the desert of Saudi Arabia, where we have to do with high pollution, intense UV radiation, high temperatures. And it's an interesting case because we have the smartCOUNT running on Tridelta surge arresters and ABB surge arresters on the same system. One of the interesting installations also was in Ukraine, one of the largest European nuclear power plant, and installed on 750 kV and 330 kV, and there was much outcome of this test installation. Finally, one special application is, of course, NGLA surge arresters, line surge arresters without gap. Therefore, the smartCOUNT can also be used. So here we have a very pretty showcase of a smartCOUNT used in Indonesia for a very recent project with line surge arresters. Now we have installed and proven the smartCOUNT worldwide and already discovered suspicious surge arresters on different locations. And I can tell you some surge arresters have been replaced now, and we found some very suspicious items, especially on the pictures you see here. We have that one surge arrestor which has been flash over due to surface contamination. We have this surge arrestor breakdown due to zinc oxide aging. We see the break in this zinc oxide block here, which is wrapped with this fiberglass tape. And on the left low end, we have the surge arrestor, which was exposed to humidity ingress. You see the corrosion already taking place on the metal parts inside the surge arrestor. So these have been some success stories where we very quickly saw that installing the smartCOUNT on old existing surge arrester does make sense, and will quickly show you the surge arresters which are suspicious or which are on the way to fail. One slide I want to show you, which has been asked yesterday very often, is what type tests have you proceeded? What routine tests are you running? So just to give you a little background of what we are doing or what we have done. Of course, we have done the typical volt or electrical tests. We also do on our surge arresters. So the devices installed on the surge arrestor should have the same performance like the surge arrestor. So we tested impulse currents up to 100 kA and leakage currents up to 50 milliamps, and QRS and TOV condition we approved. We conducted a 1000-hour accelerated aging test in our weather aging chamber. We have done IP67 tests to verify the tightness of the device. UV stability test and temperature test up to 60 degrees have been typical type tests for the device. And then we also run routine tests. For us, it's important to verify the quality of each single device we are delivering. And there we verify the power supply operation. We verify the impulse current sensitivity for lightning currents. And we verify that the leakage current measurement is precise, and we are testing all the transponder pad NFC interface that the communication is working. So this is a complete routine test to verify all the functions of the delivered devices conducted on each single delivered device. So at the end, I want to give an overview about the smartCOUNT in comparison to devices from other brands. And of course, the devices from other brands are older, were developed 10 or 20 years earlier. And today we have another state of the art in microelectronics and in materials. And of course, a recent device can be much better than a device which has been developed before 20 years. And that's why we show in the slides how much functions we have to fulfill and where we are definitely the best choice for a good monitoring device. Of course, last point is important. The smartCOUNT is a device which is made in Germany and has been developed in Germany, which we are very proud of. If I would summarize, I would speak about 3 important points for you. For you, it's an interest to minimize shutdowns or avoid shutdowns and to increase reliability of the surge arresters. Of course, this also has something got to do with your budget. You can reduce preventive maintenance effort and replacement of surge arresters if they are not damaged or bad. You can keep them inside the substation and don't exchange or replace after a while. And in the end, we will help you with that and give well-founded decisions. You can contact us over our support channel, and we will try to answer your questions properly. So thank you for your attention. I'll show you my slide here about my contact information. You can contact me directly if you have deep technical questions. And if you just want to get an overview and inform yourself a little bit more about our smartCOUNT, then you can go on the smartcount.info website, where we concentrate some information and present how the device works and so on. And you also get some downloads like the manual or like our flyer, or also like the link to the app on the Play Store and link to our smartCOUNT website. So this page is full of information for you. Please have a look at it, and I hope this will clarify the first answers from you and the first questions from you. And if not, we will have the right answers for you. Just contact us. Thank you. So now we would go over to a questions and answer session. And as I showed here, you have the possibility to raise your hand. If you raise your hand, we can give you the microphone. If you have a microphone, you can talk and ask your question. And if you want to write your question, you can click on questions and answers, Q&A, and just type in your question and we try to answer. So here's my colleague Florent. He will help me in answering your questions.
picture of yours when I talk.
Okay.
So we have a question related to the smartCOUNT. And I know you have the answer, and this is actually, we got similar question yesterday. smartCOUNT can be used without the cloud, question mark. I think just download Excel format and use it how we need, because our policy does not allow to use the cloud. And this is, I think, second question. It was mentioned that third harmonic was calculated in the cloud. So basically, it's the. I think the answer is yes. Yeah, maybe you can explain how to handle this.
Okay, we were aware of situations like this, so that's why we have included the download for the Excel. Yes, you are right. In the smartCOUNT cloud, let's say the magic happens where third harmonic current is calculated to resistive current, and this is of course the more correct way to do the monitoring. In the Excel file, you will only have the raw third harmonic value, which can also be used to do the monitoring, because you are not really interested in, let's say, absolute values. You are interested in the surge arrestor leakage current trend. And in the Excel file, you will also get all those automatical measurements, peak current and third harmonic current, and you will be able to see the trend of this. You can make your own diagrams or just integrate those values in another system just like you prefer. Just have a look at the trend, how the leakage current is developing, and you will see also the same patterns I have shown you in my slides with the 3 failure modes.
And I just want to add something. For me, it's. I mean, I can understand that there are some internal policy about the cloud, yeah. But which means those information will not be stored in the cloud, right? In that case, or
well, it depends on what the policy says. We have to clarify a little bit more precisely in detail. Maybe there is a way to find the right solution, something between. You didn't say so much about this policy, and maybe we can talk later, and you tell me what exactly is the problem, and maybe we can find a custom solution for that.
okay, yeah, and maybe I just want to say to clarify, because I have seen questions related to the, let's say, the smartphone, and so just to make it clear, the NFC technology is not compatible with the Apple product. Apple does not accept NFC technology. The smartCOUNT, sorry, so this is only compatible with Android smartphones. And this smartphone should be considered as a tool just to upload the data to the cloud. And once it's uploaded, you can have access to the cloud from any device through the browser. So you can use it from a smartphone, you can use it from your own computer, from a tablet. It really doesn't matter how you handle this. So if there are, for example, policy, if you don't have in the computer station, if you don't have internet access, or if you have some policy restriction, this database in the cloud can be accessed from anywhere. And also, it's important to mention that we can deliver Android smartphone as an accessory with the smartCOUNTs. So it could be used. It's an accessory to upload the data. So we have another question. Can the smartCOUNT be installed on 36 kV rated substation or distribution class arrestors, especially for large size distribution transformers?
So yes, this is working. We have the only limiting factor is the leakage current. I've told in my slides that we are using the leakage current for powering up the device. So there's a lower limit if the leakage current is not sufficient enough to power up the smartCOUNT, then it comes to problems. But we had no cases yet where the leakage current is so low that the smartCOUNT is not powered. I can just give you an direction. We need about 100 microamp to power up the smartCOUNT. It will just take a little while, and then it's powered up. So I can, for this question, I can say yes, it's working. So one further question: is the smartCOUNT Cloud compliant with cybersecurity protocol? Yes, it is. We are in Germany. We are having very strict regulations for that, and you have to provide some basic cybersecurity functions inside the server itself, inside the website itself, and also in the protocol for the upload of the data. So those three things have to be secured. For the server, we have implemented the server at a very professional German server hoster. They are, I would say, they are the most famous server hoster in Germany, and they have they got some prizes for their internet security of their servers. That's why we chose them. And for the smartCOUNT Cloud, the name is Hetzner. For the smartCOUNT Cloud, we have chosen a special server which is called managed server, where let's say tools and programs are installed which monitor the server and the consistency of the data in each moment. So if something happens, they will get it, they will recognize it, and they will quickly react with some cyber breach protocol, which let's say shuts down everything, brings everything back in line, and secures everything again. So there, even in the case something happens, which is not very probable, then they have like a security method to secure everything. And we are doing backups every day and every week and every month, and the data will be backed up and brought back to the server if necessary, if something gets lost. And for the account, for the user account, it is important to say that you have your own user account, you have your own login data, and you can also you can only see your own data, your own search registers you have configured, and everything is separated from each other. So this is secured, and then we have at last the upload protocol, which is like a handshake protocol where only the smartphone with the right login, with the right user account, and with the right smartCOUNT associated to this user account will be able to upload to the cloud. And in the end, we have secured the website with a HTTPS protocol, which shows that also the website at the front end is secure for the user. So 100% security.
Okay. So we have one more question. We have reached actually time is up. We've reached what time is it? 10 already. Yeah. So it's already 10 a.m. in Germany. Maybe let's answer the last question. Probably some people have some other duties. You can stay. We're gonna maybe extend a few minutes more. Just one answer from my side. We got a question about externally gap line arresters. So since you have a gap, there is no leakage current, so you cannot power the device. But in any case, I would say that smartCOUNT do not apply to externally gapped.
Especially, you don't need to monitor an externally gapped search arrestor because you have no leakage current.
That's exactly what I say. Yeah. But I mean, monitoring of let's say series varista units could be a question. So, how to make sure that your SVU is in good condition. That's often a question we have. And actually, we're going to have probably in 1 or 2 months separate webinar about line arresters. We will also focus on externally gapped line arresters. But this is a separate topic. And in my opinion, it's really not needed to monitor externally gapped such arrester. That's another topic. One question regarding the warranty length, you could answer maybe.
Well, I think you are the right person to answer this. I think it's the same warranty like for such arresters.
Yeah, exactly. I mean, there is the question of the warranty, which is of course, say, more or less standard. It also depends on requirements from different contracts we have. We are offering the standard guarantees, could be 2 or 3 years. But of course, if you request more, this is just request it, and we will of course give you feedback. But I would say in general, for me, the question of the warranty has to do with the confidence in the device, and we have let's say no issue to extend warranty is needed. I mean, you mentioned this in your presentation, but there is a key. Can you switch off the microphone? There is a key point. I think regarding the design is that it's as you can see here, you can see a smartphone. It's completely encapsulated, and so it's one of the key, I think it's one of the key features from my experience from let's say existing monitoring solution. One of the key issues that our competitors have faced is moisture ingress, and that the device is not working after a few years. So yeah, so I think this is probably the most important thing to say is that let's say we are confident with the design about it long-term stability, and we also have since you have started the development 5 years ago, we have units or say samples which are installed in different countries across the globe, which are operating very well. And this is also what I mean. We have released the device some months ago, but we already have let's say experience feedback from the field. Yes, you will get the presentation. Our colleague Yuri, she will send you an email with the presentation in PDF and also a link, because this webinar is recorded, so you will be able to watch again. If you had some fun today, you can watch it again. And yeah, last question. It's a very good question because this is exactly what I wanted to mention. Yes, I think the next webinar, end of September or early October, will be about arrestor selection and configuration. The best way to, let's say, to be updated is just to follow us on LinkedIn. I think that's the best way.
So thanks everyone for attending. Now we are open for deeper questions. You can send us by email or contact our sales team, and we will try to reply and come back to you with detailed answers, right?
Okay, thank you everybody. Have a good day or good evening.